Okay, so this is our quiz 4 about trig functions. So the most important thing is you draw the right triangle in the xy plane. Okay, xy plane. So you have to remember this is sine theta is xy over r. Cosine theta is x over r. And the relation between x, y, r is r squared is x squared plus y squared. If you have a point x, y in the plane. Okay, x, y in the plane. So let's look at the first question. Okay, the first question. So suppose our point P is 3 and -4. On the terminal side of the angle theta, find sine theta, cosine theta, and the tangent theta. So let's look at where is this triangle. It's 3, -4. Okay, it's 3, -4. So it's 3, x is positive here, so -4, so go down 4. So this is our terminal side of the, this is the terminal side of the angle theta, and here is our point P. Okay, here is our point P. So this is the right triangle. Okay, right triangle. So how to make the right triangle? You always look at P and then draw a vertical line from P. Okay, the x-axis and this vertical line will make you the right angle. And then you add the terminal side of the angle theta, you got this right triangle. So where is angle theta? It's from here to the terminal side. So this is angle theta. Okay, yeah. So now what's x and y for this P? P is, so P x y is P is 3, -4. So x is 3, y is -4. What is r? Use this relation, right? R squared is x squared plus y squared. So this is 3 squared plus -4 squared, which is 25. So r is 5. Okay, so this is the most important property. R is always positive. Okay, R is the distance. R is the distance from P to 0, so it's always positive. If you try to find x and y, you have to take positive, negative square root. Here, R is always positive, so R is 5. Okay, R is 5. So now what is sine theta? Sine theta is y over r, so it's -4 over 5. Cosine is x over r, so it's 3 over 5. And tangent is y over x is -4 over 3. Okay, over 3. So that's our first example. Okay, first example. So now let's look at the inverse function. Okay, inverse function. So now let's find sine inverse of -1 over 2. Okay, yeah. So now first we know the inverse function will give us an angle. So we assume this is angle theta. The answer is angle theta. And then we rewrite this inverse trig as a trig notation, right? Okay, so sine of theta will be -1 over 2. Okay, so this is the relation between trig and trig inverse. This is the angle theta, this is number -1 over 2. So sine function change angle to number, and sine inverse, this is sine inverse. There's a -1 here. Sine inverse change number back to the angle. Okay, back to the angle. So there's a 1-to-1 correspondence. Okay. So again, first you assume the inverse trig is some angle and then rewrite as a trig function. Then we don't have to deal with the inverse trig function. Okay, yeah, so now let's use definition of trig. So what is sine theta? Sine theta is y over r, and we already know is -1 over 2. Again, r is positive, so negative sign is on top. So we got y is -1, r is 2. Okay, r is 2. So 1, 2, what's the other side? radical 3. If you remember our special triangle, right? 1, 2, radical 3. If you don't remember, use this relation. X squared plus y squared is r squared. So we know x squared plus 1 is 4. So x squared is 3. So take square root. You have to take positive and negative square root. So x is positive and negative radical 3. Okay, so r is positive, and x and y, they could be positive or negative. So we have two solutions for x, positive radical 3 and negative radical 3. So we have two choices, right? So y is negative 1, x is positive. Y is negative 1, x is negative radical 3. Okay, so this will give us two different pictures, completely different pictures. Two right triangles in the xy plane, right? So negative 1, positive radical 3. So y is negative 1, x is radical 3 positive. So here, radical 3 positive, y is negative 1. So this is the right triangle. R is 2. Okay, so here is angle 30, the reference angle. So what's our theta? Our theta will be this from positive x to terminal side. So theta is 360 minus 30 is 330 degree. So that's the first case, x is positive. When x is negative, where's the picture? This is negative radical 3, and then y is still negative, negative 1. So this purple triangle, okay, purple triangle. So r is 2, so we know here is still 30. So, but now what's the angle? The angle will be 180 plus 30. So theta is 210. Okay, theta is 210. So that's the inverse trig function. Okay, so you change it to trig and then use definition of trig, find x, y, and r. One more example. Cosine inverse 1 over 2. So we assume this is theta, so we rewrite it. Cosine of theta is 1 over 2. Okay, so what's cosine theta? Cosine theta is x over r. So x is 1, r is 2. So y will be positive radical 3 or negative radical 3. Okay, so it's the same triangle, 1, 2, radical 3. Okay, radical 3. So we have two pictures again. So x is 1, y is positive radical 3. So x is 1, y is radical 3. So that's the red triangle. Okay, red triangle. So what's our angle? 60. So that's the angle theta. Theta is 60. Okay, so the second case, x is 1, y is negative radical 3. Okay, so x is 1, so here. And then negative radical 3. So this is the reference angle 60. So what's our angle? The angle is outside, so this is the angle theta. Theta is the whole circle minus 60, so this is 300. Okay, 300. So find x, y, r first, and then draw pictures. You're going to find the inverse trig. Okay, so now two more questions about trig values. So we will use different ideas. Okay, we will use different ideas. So now the next one is sine of 19 over 4 pi. Okay, so what is sine of 19 over 4 pi? It's bigger than 2 pi, right? It's bigger than 4 pi, so we have to change the angle. So 19 over 4 pi is 4 pi plus 3 over 4 pi. Okay, so this is 16 over 4. Okay, yeah, so 19 is 16 plus 3, so this is 4 pi plus that. 4 pi means you go around twice, right? So you have the same terminal side. So the question is sine 3 over 4 pi. Okay, so now let's draw the picture, draw the angle. Okay, draw the angle. So first we go around twice because we have this. 1, 2 pi, 2, 4 pi, right? And then this is 4 pi. And then we continue, go 3 over 4 pi. This whole thing will be 19 over 4 pi. So where's the terminal side? Here. Okay, so the angle here, the reference angle will be 40 pi over 4, so it's 45. Okay, 45. So now we know this is radical 2 negative, this is radical 2, this is 2. So what is sine? Sine of 3 over 4 pi, this is y over r, so radical 2 over 2. Cosine is negative, radical 2 over 2. Okay, cosine 3 pi over 4 is. Okay, so if the angle is too big, you draw the picture. You know where's the terminal side, where's the equivalent angle between 0 and 2 pi. You can find the trig value. Again, draw the right triangle. Okay, draw the right triangle. Okay, yeah, so now let's complete this page. The next question is cosine 15. So 15 is not our special triangle. Okay, we only know 30, 60, 45. So how can we find 15? So we use sum and difference formula. 15 is 45 minus 30, right? Minus 30. Okay, so I already did it in the lecture file. So let's try it again, right? So cosine alpha minus beta. So this is cosine alpha, cosine beta, plus sine alpha, sine beta. Okay, sine beta. So what is alpha? Alpha is 45 and beta is 30. Okay, so cosine 45 minus 30 is cosine 45 degree, cosine 30 degree plus sine 45 degree, sine 30 degree. So this is radical 2 over 2 times radical 3 over 2 plus 2 over 2 times 1 over 2. Okay? Yeah. So we know the trig values for 45 and 30. By the difference formula, we know the 15. Okay? 45 minus 30 is 15. So you put them together. This is radical 6 plus radical 2 over 4. Okay? So now the other side of the practice questions. So we have some equations like this. Sub sine 3x is 1 over 2. Okay, 1 over 2. So what's our step 1? So step 1, we change the angle. Okay, so suppose there's a new alpha, the angle is 3x. Or you can use theta. Okay, you can use theta, it's the same thing. Then we know sine of alpha is 1 over 2. Okay, so we find angle alpha first and then divide by 3, you got angle x. Okay, angle x. So this is y over r. So what is y? Y is 1, r is 2. So 1, 2. The other side, the third side is radical 3. Not 2, radical 3. Okay, you can use x squared plus y squared is r squared to find the x. Okay, if you remember 1, 2, radical 3, you know x is positive, negative radical 3. And then we have two cases, right? Two cases. So first case, y is 1, x is radical 3. So let's draw the picture. Y is 1, x is radical 3. So this is radical 3, this is 1. So we have 30, right? So this is 30. Alpha is 30. Okay, 30 degree. Okay, 30 degree. So that's the first solution. And then y is 1, x is negative radical 3. So it's on the other side, negative radical 3, go up 1. So this angle inside, the reference angle is 30. So the angle outside is 180. So alpha is 180 minus 30. So it's 150. Okay, 150. So now alpha is 30 and 150. What's x? Alpha is 3x. So x is alpha divided by 3. So this is 30 divided by 3, 10. And then x is 150 divided by 3. So it's 50. Okay, it's 50. But our question is find all the solutions between 0 and 2 pi. Okay, so we may have more solutions. Okay, so what's the next solution? So next solution, we can add some rounded rotations, right? So alpha is 30 plus 360. We have the same terminal side. Same picture, same right triangle. So this will give us a new x, right? So this new angle divided by 3. So x is, this is 390. It's 390 divided by 3 is 130. We need all the solutions, all the x between 0 and 360, okay? And then you do it again, another wrong notation. So this is 720, right? This is 750. So what is x divided by 3? 250. And you can check the next one. The next one is too big, okay? The next one is too big. So similarly, we can add. So here alpha is 150, so we can get alpha is 150 plus 360. So this will be what? This will be 510. And then x is this divided by 3. So we keep adding a round notation until x is bigger than 360, okay? So this is 5010 divided by 3, so this is 170. Okay, yeah. So the next one, alpha is 150 plus 720. So this is 870. So x is this divided by 3. 290. Okay, the next one is too big. So we have 6 solutions. 10, 130, 250. 50, 170, 290. So this is much harder than the inverse trig. Okay, inverse trig. Okay, yeah. Very hard question. Okay, very hard question. So now the next one is the equation, right? This is easier. So we know 3 cosine alpha plus 2 is cosine alpha plus 1. Okay, so first we solve this equation for the cosine alpha. We solve for cosine alpha, okay? Yeah, so minus 2, we got 3 cosine alpha is cosine alpha minus 1, right? And then minus cosine alpha. So 2 cosine alpha is negative 1. And then divided by 2, we got cosine alpha is negative 1 over 2. So now we need triangles again, right? So what's cosine alpha? Cosine alpha is x over r. So x is negative 1, r is 2, y is positive radical, negative radical is 3. Okay, 2 triangles give us 2 solutions. Okay, 2 solutions. X is negative 1, y is radical 3, positive radical 3. X is negative 1, so here positive radical 3, so we know this angle is 60. So what's our alpha? Alpha is this angle, so alpha is 180 minus 60 is 120. Okay, 120. And then the second solution, x is 1, y is negative radical 3. So this is the picture. X is negative 1, negative radical 3. So this is 60. So what's our angle alpha? Is this, right? So alpha is 180 plus 60. So this is 240. Okay, 240. So right triangle. Draw the right triangle. That's the key to solve all these trig values. Okay, all these trig values. 2 trig identity questions. So cosecant. We want to prove the trig identity. Cosecant squared is 1 plus cotangent squared. Okay, cotangent squared. So what's our step 1? Change to sine cosine, right? Change to sine x and cosine x. So what's left hand side? Left hand side is cosecant x squared. So what's cosecant? Is 1 over sine x squared. Right, so we put second power between the trig function and x. Okay, so that's the left hand side. And then let's change the right hand side. So I will use blue color for the right hand side, and we want to show they are the same, right? Right-hand side is 1 plus cotangent x squared. So cotangent is cosine over sine. Okay, so we change the cotangent. This is cotangent is cosine over sine. So now left-hand side, right-hand side, we only have sine, cosine, but it looks like different. Okay, they're not the same, so we need step 2. Okay, we need step 2. So what's our step 2? Use Pythagorean theorem. Sine squared plus cosine squared is 1. Okay, is 1. So let's look at the right-hand side now. Yeah, change it back to blue color. So right-hand side, we have 1 plus cosine x squared plus sine x squared. So now we need same common denominator. So we change number 1 to sine squared over sine squared. Okay, so I changed number 1 to this to get same denominator, sine squared. So this is plus cosine squared over sine squared. So now we can add these two fractions, right? Because they have the same denominator now. Sine squared, so numerator is sine squared plus cosine squared. You see what's the numerator? Pythagorean theorem, right? So numerator is 1. 1 over sine squared. So now you look at the left-hand side and then the right-hand side. They are exactly the same. So this is the left-hand side. We prove the identity. Left is equal to right. Okay, so to prove identity, first step, you change everything to sine, cosine, and then sometimes you need Pythagorean theorem to show left-hand side is equal to right-hand side. They're exactly the same expression. Okay, exactly the same expression. Okay, yeah. So one more formula questions. Cosine of x plus, we want to prove cosine of x plus pi over 2 is negative sine x. Okay, so this is the sum angle formula. Okay, sum angle formula. So what's the sum? Cosine alpha beta is cosine alpha cosine beta minus sine alpha sine beta. Okay, so what is our alpha? Alpha will be angle x, is this, and beta is pi over 2. Okay, pi over 2. So x plus pi over 2 is, alpha is x, so cosine x times cosine pi over 2 minus sine x times sine pi over 2. Okay, so what's cosine and sine pi over 2? So here, right, this is the angle pi over 2. Right angle, okay, right angle. So this is point P is 0, 1. So x is 0, y is 1, r is 1. Okay, so this is cosine x. So cosine is x over r. So it's 0 over 1 is 0 minus sine is y over r, so it's 1. So this is 0 canceled. We got negative sine x. Okay, so left-hand side is equal to the right-hand side. We proved the identity by using the sum formula. Okay, sum formula. The last question in this review list for the quiz 4 is the graph question. Okay, graph question. We want to get the graph of y is 2 sine 3x minus pi. Okay, 3x minus pi. So what's ABC? So A is 2, B is 3, and then C is pi. Okay, C is pi. C is not important. Okay, C is not important. So first amplitude is A, the absolute value of A, so it's 2. Okay, and then period of the graph is 2 pi over B. You have to remember the formula, so it's 2 pi over 3. That's the period of the graph. And then phase shift. How can we find phase shift? We solve this equal to 0. Okay, whatever in this trig function, we solve it equal to 0. So 3x minus pi is 0. So 3x is pi plus pi divided by 3. So we know x is pi over 3. So this is the phase shift. The phase shift is pi over 3. Okay, that means you move one period of the graph to the right, pi over 3. Another understanding, this is the beginning of the one period graph. Okay, so what's the one period graph of sine function? It starts from 0, go up, go down, go back to 0. So this is one period. Okay, so what's the starting point? The starting point is the phase shift. Okay, so this is pi over 3. The starting point of the first period. Okay, and then what's the end point? The end point is this point is phase shift plus the period. So here for this particular example is pi over 3 plus 2 pi over 3. And this is pi. Okay, this is pi. So the graph is between pi over 3 and pi. Okay, and then we put x and y axis after you know this information. Okay, so that's the answer for the graphing problem. So if A is negative, that's the remark. If A is negative, you have the reflection. Okay, note. If A is negative, then reflect. Okay, yeah. So that's the end of my questions in the review list for quiz 4. The quiz 4 is very similar to these questions, okay?